All right, first one right off the bat, parallel lines. I know you talked about it last year in algebra. Probably you guys graphed them and you said the slopes were equal to each other. That's algebra parallel lines. Now let me bring it to geometry. Can you guys help me make my cube that I had yesterday? So I need a cube for a picture here for the parallel lines. What's up, man? How you doing, man?
Good, how are you?
Great. Good to see you. We're going to finish notes early, so just at the end of class, remind me I got to just check your homework, all right? All right, so let's talk. Yesterday we said, all right, with a cube, how many planes do I have? How many planes on a cube? 6. I want you to focus on one of those planes for me right now, one of those 6 planes, and pick 2 lines off one of those 6 planes that do not intersect. Those are parallel. All right, so pick a plane. Give me 2 lines off your plane that do not intersect, aka they are parallel. Okay, so give me 2 lines off your plane right now that you are saying are parallel to each other. 16, going deep, Steve. AD and CB. Yep, those are parallel to each other. Everyone see why? They're on the same plane, the front plane, and they don't intersect. Notice I didn't put anything in between because I'm not going to have you guys write it's parallel to. We have a symbol for parallel. Anybody remember it from last year? I'll let you show off a little bit, honors kids. Anybody remember the symbol for parallel from last year? Going. What do you got for me, Josh?
There's like 2 lines that are like that.
Not diagonal. They are 2 lines. They're not diagonal. Tip them. Rotate them a little bit. They're not diagonal. They are. Go this way. Vertical to each other. All right, so there you go. There's your symbol for parallel, and let's start using it, please. All right, make sure you make a note. There's your symbol for parallel. All right, so anytime you tell me 2 lines are parallel, let's use the symbol. What class are we in? Honors. So 1 doesn't make you great. Give me another one. Dig deep. 9. Ian? A, B, and GH, the bottom ones. Yep, I like it. A, B. Parallel to GH. Got it. All right, you guys are on your own now. 1, 2, 3. Give me a line that's parallel to each of those 3 in my diagram. All right, so AC, EF, and AD. Find a line that's parallel to each of them in my diagram. Give you about a minute. All right, AC. What are you finding? Give me something that's parallel to AC. 5. Where are we going here? Hi, Haley.
DF.
DF. Good job. Something that's parallel to EF. Let's keep this train rolling. Oh, hi, Haley again.
BC.
BC. Good. And then finally, how about something that's parallel to AD? I will accept 2 answers here. 2. I just want 1 from you, though. Oh, triples. 3 bag. Can we just all the 3 bagger right there? That's a rare moment right there. The 3 bagger. Go ahead.
CF.
CF. Yep, I would have also accepted BE. That right there is like 3 sneezes in a row right there. You don't see that much, right? You don't see that much. All right, good job. So everyone's good with parallel. All right, now I'm going to introduce a concept that's a little bit different. Skew lines. Skew. Now let's go over this definition here. They can't be on the same plane. Okay, that's not bad. They can't be on the same plane. They can't be parallel. Okay. But they can't intersect. Then I just count. How's that happen? They can't be parallel and they can't. What am I left with? I'm left with nothing. No, no, no. Everybody ready? Yeah, just hold up my keyboard here real quick so everybody can see that thing. All right, everyone ready? Here are your skew lines. Everyone sees this line I have on my plane, my cube right now. And everyone see the bottom one I just put in there. Are they on the same plane? Are these two lines I just made on the same plane? Nope. Are they parallel? Absolutely not. Now, will they ever intersect? We're in three-dimensional space here. Will they ever intersect? Absolutely not. Do you see what I mean by skew lines? Not on the same plane. Shoulder, all right? Okay, good. They're not parallel and they're not intersecting. All good? Okay, good job. So now let's look at my diagram. Let's see if we really understand this. Give me a line that would be skew to AC. So something that's not on the same plane as AC, not parallel to it, and will never intersect it. Anybody have anything they want to throw out there? I won't call on anybody with the numbers on this one. Anything that you think is skew to AC? Skew to AC, Matt, what do you got? DE. DE. I like DE, yep. One of many you could have given me there. DE, good. How about anything that's skew to EF now? Anybody want to throw something that's skew to EF? Ian? AC, yep, good. Now, I just want to make a point here because some people argue with me every year. Well, wait a second. Look, here's EF, here's AC. They're going to intersect. Yeah, on your paper they will because your pencil lines are two-dimensional. All right, but if I took this out and we had this and I could hold it in my hand and I put one on AC and one on EF, they're not intersecting. Okay, so yeah, I know they're going to intersect on your paper because it's two-dimensional. And then anything on AD? Anybody want to throw one out for AD? Skew to AD. Skew to AD. One more time. Skew to AD. What do you got for me, BC. Let's see. AD, BC. Yep, they're good to me. Could have all said EF there. That would have been fine. What's up?
Is there a symbol to show skew lines?
SKEW. Good? So that your answer to your question is no. If there's a symbol, I will show you. Okay, if there is a symbol, I will definitely show you. We don't come up with our own. That's my one rule here. Any questions, comments, concerns? All right, let's see what else we got going on today. Jeannie, thank you. Good. Try and help you guys out. It's going to make an appearance and you're going to be stuck. You're like, oh, well, I don't know what to nominate and what to guess. Parallel planes. Going to go quick here. Parallel planes. Two planes that don't intersect. Done. Two planes. In my diagram here, there's only one set of parallel planes. Can you find them for me and name them correctly? There's only one set of parallel planes in my diagram. What are they? Relax, relax. I'm actually going to call on somebody. Oh, almost had it. 13. Ksenia, how did I do? All right, I'm getting there. I got it. Go ahead. You got it for me? Okay, hold on. Ready? Plane. There's no symbol. We talked about this yesterday. Plane ABC parallel to DEF. Good work. Yep, start using the parallel symbol, please. And then how about 8? Okay, Mr. Phil, I get the plane parallel to a plane, and I get the line parallel to a line, but now you're asking me for a plane parallel to a line? I can have one of each parallel to each other? Yes, you can! Here's how. Remember the two planes we just had parallel? If two planes are parallel, one of the planes is parallel to any line in the other one. Okay, so if two planes are parallel, one plane is parallel to any line in the other. So, plane ABC would be parallel to any line in plane DEF. So pick your line. It doesn't matter. All right, I'll do DE. All right, everyone good? Two planes are parallel. A line in one is parallel to the plane in the other. All right, good. We're all solid there? A lot of vocab, huh? A lot of vocab. All right, yesterday, I went nuts when I showed you guys a line and how to draw it. I said, if you're drawing a line, it's got to have what on it? Arrows. And I said, darn it, if you take the two arrows off, that's a totally new vocabulary term. And here it is. You take the arrows off a line, you have now what's called a line segment. A segment. A segment has endpoints. Okay, endpoints. What's in between the two endpoints? Infinite points. So I want to throw on a couple more points to prove something here. So let's throw on E, F, and G here. How do I name my original segment now? Because remember yesterday with a line, you can name it with any of the points, right? Any points on the line you can name it with as long as there's 2 points. If I want to name my original line segment, I have to use I have to use the original 2 endpoints. So I would need to call that CD or DC. It's not annoying at all. So CD or DC. You cannot use any points in between. It's got to be the endpoints. All good? All right, here's where I start having a lot of fun. This is where now geometry mixes with algebra. So hopefully you guys aren't going to start sweating profusely or have nightmares from last year, but here's where some of the stuff you learned last year mixes in with this year. All right? So first up, talk to me. Draw line segment EG. Can we do that? Go ahead, draw line segment EG for me. Where F is a point on the segment. So go ahead, throw a point F somewhere. It doesn't say where it has to be, so just throw a point F on there. All right, now, hey, alert here, lock in for me. What did I just drop here from EG? What's not there anymore? What's missing? The line segment symbol. If that line segment symbol is not there anymore, I am now talking about the length of EG, how long it is. 100, I don't know, centimeters, inches, it doesn't matter. It's got a length of 100. All right, so I'm going to show it, and I don't care how you show it on yours, but this thing is 100 units long. Okay, so if you do not see the line segment symbol anymore, it is telling you how long it is. I dropped it again, didn't I? EF, I dropped it. It's not there anymore. So that tells me EF has a length of 4x minus 20. So EF is 4x minus 20. And I dropped the symbol from FG. FG, 2x plus 30. Usually in here, I always tell you got one job. But here you got 3. You got to find x. What's the value of x? I don't have the line segment symbol here on EF, right? So I want you to find how long it is. And don't, that's an easy one. Look, EF is 4x minus 20. No. How long, give me a number how long it is. All right, I don't want 4x minus 20. And then how long FG is. So I need your help, honors kids. If you're going to ask me to solve for x, you're probably going to have to set up an equation so I can solve it. So I'm going to need your help setting up that equation. All right, you know the whole thing is 100. Each piece 4x minus 20 and 2x plus 30. Using all 3 of those pieces of information, how can you help me write an equation that says, hey, this is how you're going to solve for x? Want to go, Matt? Sure, go ahead, show off a little bit.
4x plus 20. I mean, times 20. Plus.
Times.
Wait. Oh, minus. Yeah.
4x minus 20.
Plus 2x plus 30.
Okay, hold on before you tell me the rest. Does everyone see what Matt's doing? He's taking each piece, adding them together because he knows when I add them together, it totals what?
100.
Equals 100. Is everyone seeing where we're getting that from? Right? I know some of you are like, this is so basic. I get it. Good. That's good that if it is. I know some of you are like, wait a second. All right? I'm taking each segment and adding them together to get the whole length. And I'll be very, very honest with you. I can't help you here. All right, you got to know what's going on if you made it this far to honors geometry. All right, you got to know how to solve that. I can't help you there. That's last year, probably even before that. 6x plus 10 equals 100. 6x equals 90. And if you need it, you got your calcs. I'm not the type. I'm always the one that says if you have it, use it. I am not the type, oh, you should not need a calculator for that. Okay, who cares? If you have it, use it. And what do you got for me for X? 3. Aiden, what do you got? 15. Good work. All right, there's one job done. Now you got to go to the other 2. I know X is 15. How would you help me find EF now, the length of EF? What's your plan for that? 8. What's your plan? Josh, not what the answer is. What's your plan?
You substitute 15.
Yep. I take 15. I substitute it in for X and 4X minus 20. Little substitution. You got EF, Josh? Want to finish it?
It's 40.
40, yep. And now go ahead and find FG. You can do it the same way. Substitute in X, or you could say, oh, the whole thing was 100. The first piece was 40. FG, what are we looking at FG for here? Ooh, Josh, again, 8. 60. Algebra meets geometry. That's where we're going to live here.
We have to show where the second part.
What do you mean the second part?
Like
Where I got the 40 and the 60?
Yeah.
No. Here's where I need right here. Here, bare minimum, I need to see the equation you set up, answer, and then the other, that's about it. Yep. Okay. Anything else? Okay, we got one more topic and we're done for the day here. And this is a pretty important one. Swing. Good job, man. Good. You've been memorizing. Good. I know you don't have this. I know. I deleted that this year. You don't have this. You guys have congruent segments, though. And that is a word you need to become familiar with. We're going to use it all throughout the year, guaranteed. Here's what congruent segments are. 2 segments that have the same measure, but I don't know what the measure is. All right, I know they're the same length. I don't know if they're 7 inches, 7 inches, 18 feet, 18 feet. I don't know, but you know what? I know they're the same length. That's what congruent means. All right, I know they're the same length. I just don't know what the actual length is. So can you do me a favor? Draw a line segment CD where it says picture. Draw a line segment CD for me. Right below it, not connected. Draw a line segment EF that looks about the same length as CD. All right. Right now, we do not know if they're the same length. Never, ever in this class will you tell me they're the same length because it looks like it. That will never be a response. So, what will be on these segments in your textbook test quizzes that say they're congruent? You will see markings called hash marks on them. All right? You will see this on them. I see these markings called hash marks. You now know they're congruent. Oh, getting crazy in here. You now know they're congruent by the hash marks. Okay? You need them to say they're congruent. Without them, you are telling me nothing. Squat. You can't tell me anything about those line segments. Once you see the hash marks, oh, now they're congruent. That means they have the same length. All right? Next thing, how do I write this symbolically? Do you already know how to write line segment CD and EF, I hope? You know how to write that, right? CD, EF, put a little space in between them. All right. Anybody, I'll let you show off in front of your peers here. Anybody know the congruent symbol? I've seen it before. Or have anything about it. I don't even need the whole thing. Anything about the congruent symbol you want to add in. Nobody. Never seen it? Okay. Part of it is the equal sign. Okay? Part of it is the equal sign. With an addition. Not the addition symbol, but something added onto it. Gonna try it? Anybody?
A line through the middle. Just gonna say.
A third line in the middle?
That'd be like a line through the middle.
That'd be not equal to. Right? That would be not equal to. I want an equal though. Not bad. That's the first time I've heard that, Jen. Is this right here? That. Usually I hear, oh, it's the squiggly. That is the least mathematical thing you could ever say. Have some self-respect. Don't embarrass the math community. Don't say squiggle. Up, S turned sideways is pretty good. There's an official name to it. Anybody know it? Just that symbol alone? No? Tilde? Tilde? That's what that's called. So you can impress your friends later at lunch if you haven't had it yet. But that is the symbol for congruent. There's your symbol for congruent. Do not write this on your notes. I have a problem and I need your help with. Let's say I have a diagram that already has these two segments congruent. In addition to that, that diagram also has another two that are congruent, but they're not congruent to the other two. How would you think I would show these two? Because I can't put, right? I can't do this because that would mean all four, which is false. Gianna, go ahead. Darn right, you do 2 hash marks. Great work. All right, you do 2. All right, you might have 3 on another pair. All right, it all depends on how many we're showing. All right, good work, everyone. Last question. Don't even read it. Don't even read it. This is the mode I need you to get in. A question has a diagram. Look at the diagram and already tell me what you know is true. All right, forget about the multiple choice and the actual question. Look at my diagram. Does everyone see the hash marks? What's automatically true now?
The congruent.
What's congruent? Talk to me.
The line segments are
Name them. They got names.
A, B, and CD.
So already we know before we start the problem, AB is congruent to CD, which means they have the same length. Yes, they have the same length. All good. Just by looking at the diagram, and because I provided you with the hash marks, we already know AB congruent to CD, and AB has the same length as CD. So now we can go to the question, which one of these 4 below is incorrect? Incorrect. Is AB congruent to CD? True or false? True. Why? Easy explanation. Because I told you, the hash marks are there, right? So that's true. Everyone see why? What's this mean again when I drop the line segment symbol? What's this telling? Is AB the same length as CD? Yes. Ready? Come on now. Because they're congruent. That's the definition of congruent. They have the same length. Now we're really going to get honors level. Buckle up. Do you think AC is congruent to BD? Now, I know I don't have any markings on them, but can we still say they're congruent? Ready? Everyone focus on line segment AC only. AC only. AC is made up of AB plus what other line segment? What do I need to add on to AB to get to AC? Everyone, BC, everyone agrees there? Are we good so far? Watch where I'm going with this. All right, name the 2 segments that make up BD by adding them together. CD, along with what other segment? BC, everybody? Ready? What do you know about these two. Whoops. What do you know about these two right here? What do we already know? Congruent, same length. What am I adding on to both of them? Same length. So should the results be the same? These two are already the same length, and I'm adding on the same thing, so the result should be the same. So that is correct. So the only one that's not, AC, is definitely not congruent to CD. Why not? Because what's CD equal to? AB, but I got to add on to AB to get AC, so there's no way those two can be equal. All right? 2 things for your homework tonight. One, half of it's out of the packet. You're going to flip the page and do that part, and then the other part is out of the textbook. All right? Can you flip your packet for me over to page 9? The directions say at the end, if it's false, explain it. I don't just say true or false, because most of you guys are going to be like, it's false because I can look at a diagram. All right, that's why it's false, because I'm looking at the diagram and I can tell it's false. All right, so just do true or false for me there, then go right to your textbook. You guys got plenty of time here. We don't get out until, what's this, 5th period, 11:40? So you got plenty of time. All right, don't pack up early and hover around the door. We work right to the bell in this honors class. Good work today.